All right, lesson 40 for algebra today. Let's do page 160, lesson 40. Let's talk about a few things. The first thing I want to talk about is the quotient rule for exponents. So let's look at our definitions here. All right, so here's our first definition, that x times x times x times x times lots of x's equals x to the nth power, right? Okay, n represents the number of factors. Well, with the product rule, if x is not 0, then x to the nth power times x to the n equals x times m plus n. Definition, again, another definition. X to the first power equals x, it equals itself. Another definition with that, if x is not 0, then x to the negative nth power equals 1 over x n. We do the reciprocal. And another definition, x is not 0, then x to the 0 power equals 1. Okay, so that's a review. What we're talking about today is the quotient rule for exponents. The quotient rule for exponents. This is an extension of this definition. Okay, so we're going to extend the definition. So what that means is, what happens if we want to multiply this? What does that mean? We can use this definition here to help us to solve that. Okay? So here's our problem right there. How do we solve it? Well, let's do it. Let's use the definition. X to the fifth times, all right, my phone was ringing and it's unbelievable how many times it happens. So where I left off was we're trying to figure out what happens with this one. Well, let's use that product rule here. Let's flip this one, x to the negative second power. And as we learn our rules, then it's going to be x to the third power when we are complete. So the rule for that is x over m, xm over xn equals xm minus n, or 1 over xn minus m, because we can use these kind of interchangeably. Okay, so that's going to be a key component to today's lesson. So let's take care of this one. And in this one, I want to write the answer, so the answer is in the numerator. So if the answer is in the numerator, then I'm going to get x to the 6th and x to the negative 4th, which gives me x 6 minus 4, which equals x squared. Okay, now I'm going to do the exact same problem, x to the 4th over x to the 6th over x to the 4th. This time, write my answer in the denominator. So that's 1 over x4, x negative 6 equals 1 over x4 minus 6 to the 4 minus 6 power equals 1 over x negative 2. All right, that's the quotient rule. And if we use the quotient rule, we can eliminate some of that step, so we don't need to write everything out like I just did. I could go from here to here pretty quickly. Now, let's simplify this one. Okay, I'm going to work this problem twice. Once with the numerator, once with the denominator. So the numerator gives me this. This one is already negative, so when I bring it up here, it becomes positive, x to the 10th. Now, if I write the same problem with the denominator, then I end up with this. Because I'm bringing, this time, I'm going to bring over here, sorry, I'm going to bring the x down, so that's going to become negative. And I get 1 over x to the negative 10th power. do a couple more. And again, I'm going to work this problem twice. Let's use the quotient rule. X in the numerator. I'm sorry, I want my exponents in the numerator. So I'm going to bring the b up. So that's going to be negative b. So x, negative a, negative b. Okay, that's all I can do. Now if I want to write it with the exponent in the denominator, then it's going to be x, and I'm going to bring my a down, so it's going to be positive a plus b or b plus a. These are equivalent expressions, which means they have the same value no matter which non-zero real number is used as a replacement for x. These are pretty much the same thing, they're just written different ways. Okay, so what that means for us is we can simplify things. Okay, so this is kind of going to be a preference thing. Every time we get something equivalent and there's more than one way to do it, we come into a preference thing unless you are told otherwise. Okay, we can write this 4 different ways. Okay, so that's what I'm going to do. I'm going to write this 4 different ways. All the variables in the numerator start with x. So negative x. So I'm going to bring this one up, right? Change my color, and then I'm going to have. So let's write this out first. Here's my answer. Okay, so this is what I did to get that answer. So first I brought that x up. Then I'm going to bring the y up. That's going to be 6 minus 2. And then I'm going to take care of my z. And when I bring my z up, that becomes positive 3. So 3 and 1, z and 4. All right. Now there's same problem. There's another way I can write that. Another way I can write this problem is I could write everything in the denominator. So that's going to equal 1 over. I'm going to do the exact same thing. I'm going to bring stuff down now. Okay, so what did I do this time? I brought my 5 down, that became positive. I brought my y down, that became negative, and negative 6 and 2 is negative 4. And I brought my z down, and it became negative 4. Okay? There's 2 other ways I can write this problem. I could write all exponents positive. I want all exponents positive. So in this case, I want to bring my x down, and I want to bring my z up. My y will stay, right? And I got to move everything. My x is going to go down. My y is going to go up because that'll keep it positive. And my z will go up to keep that positive. So I get y to the 4th, z to the 4th over x to the 6th. Now if I want to write all exponents negative, I'm going to do the exact opposite. I'm going to bring that little x on the denominator up to give me x to the negative 6. But both y to the 6 and z both have to go down. Okay, to keep it that way. So I get y to negative 4th, z to the 4th. So as you can see, we can do it 4 different ways. And we're going to apply that to the distributive property of rational expressions that contain negative exponents. So here's the problem. All right, so first off, I need to do the distributive property to take care of stuff. You know what? I'm going to do a different problem. Let's erase this one. Let's start again. Let's do the distributive property to take care of some stuff. Something that's a little more convoluted. All right, so let's use the distributive property to take care of this. If I use the distributive property, then I'm going to get 4x negative 2 y to the 4th x squared all over y to the 4th. And all I did was I carried that to there. I'm going to do the same thing over here. Minus, that's what it is. 4 times 3 is 12, right? 4 times 3 is 12. X to the negative second. X to the fourth. Okay, then I haven't taken care of anything yet. And on the bottom, y to the fourth, y to the negative second. I want to write this problem with all exponents positive. All right, so let's take a look at the first term here. All exponents positive. When I do that, well, 4 minus 4, that's gone. Negative 2 and 2, that's gone. So first off, I have 4 minus. Now down here, over here, let's take a look at what I got going on here. Okay, these two are going to yield me y squared. And on the top, that 12 isn't going anywhere. And my x's take care of some of that, x squared. Look to make sure all my exponents are positive, and my problem is solved, albeit a little spread apart. Let's try another one. K squared b over p minus negative 2 power ab negative first power over k squared minus 4p squared over b. I want all my variables in the denominator. So first, distributive property. Okay, and let's just leave it all out there. Why try to combine stuff when I'm going to be deleting stuff and moving stuff around? Okay, so I'm distributing, but I'm not doing any combining. Okay, didn't do any combining. I got it all taken care of now. I want all of my variables in the denominator, so every variable is going to go down. So that means that's going to be a 1 here. Okay, every variable is going down. So what happens? Well, my k's are going to go away because 2 minus 2. And my b's right here take care of themselves because 1 minus 1. So I will bring my a down, a negative 1. My p is fine, so negative 2. Now over here, my 4 is the only thing on top because that's not a variable. When I bring the p down, I get p to negative fourth power. And then I look at bringing my k down. I bring my k down, I get k to negative second power, and my b's cancel each other out. That's going down and adding, and that's how I get my problem. So try C and D on page 163.